We'll begin looking at the simplest case of the equal variance or pooled variance t-test. So with the MRSA regions data opened for percent antibiotic resistant with the east-west created region, we're going to go into analyze, fit y by x. We're going to put 2011 as our y and region, or east-west, as our x, and press OK. So we see the familiar Anova graph. So we have east, we have west, we have dots for the individual states. We have the mean line, that's the average across all states, disregarding the group. We can do a couple of things. If we'd like to, we could remove the x-axis proportional. We could ask for means and standard deviations. We could ask for quantiles. We could assess for normality. And we can take a look and see here again that the dots for each group follow the straight line pretty well in most cases. Certainly would be within confidence bounds. We have a little bit of wobble at the end, but nothing that we'd be concerned about. In addition to that, our total sample size is greater than 30 to meet the central limit theorem. Our group sizes are of decent size. And we have looked at the distribution of 2011 overall. And we can do that here again and ask for the normal quantile plot for 2011, and it will show us that we have relatively normally distributed data. And remember, under the null hypothesis, we don't have two different groups. We have one group, and we always operate under the null hypothesis. And under the null hypothesis, our 2011 data appears to be normally distributed. In addition to that, to report means and standard deviations, our group data appears to be relatively normally distributed. In addition to that, our standard deviations appear to be pretty consistent with one another, and our group size is just under 1.5 times different, and our lines here in the normal quantile lot are relatively parallel. All of these things indicate that we can use a pooled variance t-test. There are two ways to get this out of JMP, and we'll look at both of them. So we can go into the red drop-down menu, and we can ask for the Anova pooled t. So if we make this a little bit smaller and hide our quantiles, we can then get all of this into the same window here to take a look at. For now, we can ignore the summary of fit. We'll talk about that later more when we get into modeling. But what it does tell us is that we have our overall mean here of 49.1 and our 42 states contributing to 2011. In addition to that, JMP will tell us in two different locations that we're using equal or pooled estimates of variance. So here under the t-test, you can see it's assuming equal variances. It is also telling us it's done west minus east for our t-test comparison. Down here in the means for the one-way Anova, we can see that JMP is telling us the standard error uses a pooled estimate for error variance. The way that you know that is look at the standard errors for the one-way Anova versus the standard errors for the observed data. They're slightly different. We have a standard error of 2.0 for east under the one-way Anova pooled estimate, and we have a standard error of 1.9 for east in the observed raw data. The one-way Anova uses a pooled variance or an equal variance, and of course to get the standard error you divide by the square root of the sample size. If we had equal sample sizes in our groups, our standard error estimates here would be identical. But they are different because we have unequal group sizes. That's okay. What we want to do is look at our t-test results, or you can look at your Anova f-test test results, and those are both right here. The F-test, the Anova F-test, is a two-sided test. That is the null hypothesis of equality and the alternative hypothesis of not equal. You will notice here that the F-test and the T-test for the two-sided results, that is this result right here, the 0.0065, and the T-test result of 0.0065 here are identical. So Anova is giving us a two-sided test result equivalent to the two-sided test result from a T-test. What you would also notice is that if you took the square root of 8.2353, you would get 2.86972. If we have a one-sided test, we can then align our alternative hypotheses with the t-test to obtain the appropriate one-sided p-values here. If you wanted JUMP to do west minus east, then you have the results here. If you wanted to see east minus west, we could go into the column information. We could go into value ordering. We could move east down and press OK. Then we can actually go back here and under the main red arrow, ask JUMP to redo the analysis, or you could simply start over from the main analysis window. But what I want you to see here is that, of course, you can see now that we have west minus east here on the left. We have east minus west here on the right. And what you'll notice is that our two-sided p-values are identical. The only difference here is that the difference in the percentage between the two groups is negative for west minus east, because west is 43.8 and east is 52.8. Whereas over here, east minus west, we're doing the larger minus the smaller, and that gives us a positive value. The standard errors of the differences are the same. The upper and lower confidence bound values are identical. They've just been swapped and become positive. Our T ratios are identical, but again, it's become a positive T ratio. And then our one-sided P values have been switched once we switch the order, though the interpretation of them will remain the same. Obviously, what this is telling us is if we had a one-sided test asking if east was greater than west, the answer is yes on the right. On the left, if we had a one-sided test asking if west was less than east, the answer is yes. So west less than east is the same test as east less than west, and you will just find them in different places depending upon how you do your subtraction. This is why it's incredibly important to do your preliminary analyses like we have here to understand which means are associated with which groups, so that when we see the difference estimated, we know which direction the subtraction was done in. In either way, for either side, you'd come to the same conclusion for all three sets of hypotheses. In this case, the two-sided hypothesis test for equality or not equality tells us that they are statistically significantly different. And we have observed West to have a lower percentage positive for antibiotic-resistant MRSA than for Eastern states. Up next, we'll look at special situations for the t-test where we don't meet normality or where we're not comfortable with the equal variance of our two groups.